Good afternoon. We are filming our second video lesson for the weather and climate class for summer 2018. And this lesson is all about mid-latitude cyclones, warm fronts and cold fronts. We might talk a little bit about stability. This is basically chapter 9, by the way. Okay, so let's walk over here. There is some light glare and I can't seem to get rid of it. Anyway, this is our mid-latitude cyclone. Okay, where you see the big red L, that is where the low pressure center is located. So we show it with an L for low. We tend to show it in red for warm air, rising air. So you see a red line on the front there with semicircles. That's our warm front on the leading edge. You see a blue line on the trailing edge with triangles. That is the cold front. In green, I've tried to outline where we will find cloud cover. Yes, it kind of looks like an alien or a jellyfish or a comma with two tails. That's just how it is. I think in your PowerPoints, there's a satellite image of a mid-latitude cyclone showing how big these things are and that they cover, gosh, like a third of the United States at one time. So let's move on over here and talk about this a little bit more. Okay, so mid-latitude cyclones, what can we say about them? They are the primary weather producers in the United States, and they move from west to east because we are in a band of winds known as the westerlies. And if you watched the video from last summer that I just put up the other day, I attempted to draw those weather patterns. I think starting with a big empty circle and drawing them makes them a little bit easier to remember. Anyway, because we're in the westerlies, these mid-latitude cyclones move from the west to the east. All right, so what else can we say about this? There is a warm front on the leading edge and a cold front on the trailing edge, as you can see right here. By the way, the warm front moves slower than the cold front. That means that as these things move across the United States, the cold front catches up to the warm front. That gives you something called an occluded front. And on a weather map or the Weather Channel, they'll show an occluded front with purple. We don't have that here. That is not necessary to this video lesson. All right, so other things we want to say here. Okay, so let's focus on the warm front. So what can we say about the warm front? Well, it's shown as a red line with red semicircles on the weather map. Warm air moves in. That warm air tends to be less dense than surrounding air. That means it's going to rise. The fact that it's rising makes it potentially unstable. What's unstable about rising air? As it rises, it's going to cool. It's going to cool adiabatically. If you remember reading this in the PowerPoints or your e-text, that just means that it's cooling by expansion. We know that things cool as they go up. Everybody knows that there's snow at the top of Mount Everest all year long. There is snow actually at the equator if it's up high in the Andes Mountains, simply because of elevation. Air cools as it rises. Eventually you're going to reach what they call the lifting condensation level, LCL for short here. It just means that the air has cooled to the dew point temperature. You're not going to have condensation now. You're not going to have cloud formation. Rain is likely, but it could just be spotty rain or gentle rain that goes on for a day or two. And you tend to expect nimbostratus clouds with that. I think there's pictures of nimbostratus clouds in the PowerPoints and in your textbooks somewhere. All right, so the cold front, let's scoot over here. All right, so the cold front. When the cold front hits you, what happens is you have a cooler air mass moving in. Now, this gives you a clash of air masses. Okay, so the greater difference you have, say, in temperature and moisture content between these two air masses, the greater difference that you have when these air masses clash, that can cause instability. So you are likely to get thunderstorms along these cold fronts. And perhaps the supercell thunderstorms, which are the biggest, scariest kind of storms, they're the ones that are likely to produce hail. Colorado's been getting a lot of really big hail lately. I don't know if you guys watch the Weather Channel as much as I do. They've gotten a lot of hail. Anyway, Also, the supercell thunderstorms are capable of producing tornadoes. So I hope to do more video lessons next week, and we can talk more about, say, hurricanes and tornadoes then. Anyway, so we expect the possibility for violent weather with the cold front. The good news is that that cold front moves quickly, so that violent weather should move away pretty fast. Now, what we expect behind that, as that cold front moves on away from your area and continues its journey east, the air mass behind it is cooler, dense, stable, and sinking. What I did not put up here is talking about stability, and I have to remember, or admit I can't remember what chapter stability is in. We can just mention some things. Stable air is air that is cooler, cold air. Why is it stable? Because cold air will sink. If it resists lifting, if it resists vertical movement, then that air mass is stable. You don't expect to build any cumulonimbus clouds and afternoon thunderstorms. That's what we consider to be stable air. Oh, by the way, I meant to write down cumulonimbus clouds here with our cold front thunderstorms. We'll talk more about those clouds in a later chapter. Okay, so unstable air, air that is warmer than surrounding air, is unstable. Why? Because it will rise. It is going to move vertically. It's going to rise up. Again, why does that make it unstable? Because as it rises, depending upon what your adiabatic rate is at that time, or how much cooling you're getting with elevation, you can end up building up some afternoon thunderstorms. All right, so just a little snippet there of stable air and unstable air. Okay, so this will conclude our video lesson for today.